It slept for centuries, silent, buried, forgotten. Deep beneath the Mediterranean, something ancient shifted. Not a myth, not a theory, a signal. A volcano scientists believed was stable has stirred after 400 years of silence. Instruments detected it first, a sudden pulse rising from the depths below Santorini's caldera. Not background noise, not routine activity. A precise surge of underground pressure. Experts reviewed the data again and again. The pattern didn't match anything typical. It wasn't random tremors or harmless movement in the crust. It was controlled, focused, intentional, like the Earth itself tightening its grip before a release. The last time this system awakened, history changed. Entire coastlines were reshaped, civilizations vanished, skies darkened, seas surged. The Mediterranean remembers what happens when this volcano breathes. And now, it's breathing again. Sensors confirm the pressure waves are real, stronger than expected, deeper than predicted, rising from a layer of magma no one believed was active anymore. Scientists once thought this chamber had cooled, hardened, died. They were wrong. What makes this signal unsettling isn't just its strength, it's its origin. The movement isn't coming from the main crater everyone watches. Not from the known vents, not from mapped channels. It's coming from somewhere deeper, somewhere hidden, somewhere no eruption model predicted. And that changes everything, because when pressure builds in an unmapped chamber, there are no reliable forecasts, no proven timelines, no guarantees. The Earth doesn't follow human calculations. It follows physics, heat and force. And those forces are now shifting beneath one of the world's most famous volcanic islands. Researchers monitoring the region describe the activity with one word: unusual, not dangerous, not safe. Unusual. In scientific language, that word carries weight. It means the signals don't fit known patterns. It means instruments are recording behavior that shouldn't be happening. It means something underground is evolving, and evolution beneath a volcano is never casual. Right now, the surface looks peaceful. White cliffs, blue water, tourists walking sunlit streets, boats drifting across the caldera. From above, Santorini appears calm, almost frozen in beauty. But miles below that calm surface, pressure is building inside rock that hasn't moved in centuries. Heat is rising through fractures too deep to see. Gas is shifting through channels older than recorded history. The island is quiet, the ocean is still, the sky is clear. Only the instruments know the truth. Something has awakened beneath Santorini. And whatever it is, it's just getting started. Question for viewers. Do you think this is a real warning sign or just coincidence? Type yes or no. Santorini is not just an island. It is the exposed rim of a colossal underwater volcano, a structure so vast that what people see above sea level is only a fraction of its true size. Beneath the bright cliffs and peaceful waters lies a buried system of molten rock, pressurized gas, and fractured stone stretching deep into the Earth's crust. Most of it is invisible. All of it is active. Far below the surface rests a magma network powerful enough to transform the entire region if it becomes unstable. This is not speculation. Geological scans confirm a complex chamber system, layered and interconnected, storing heat and pressure accumulated over centuries. The deeper sections remain largely unexplored, not because scientists aren't trying, but because technology still struggles to fully map structures at that depth. Monitoring stations surrounding Santorini constantly measure subtle environmental changes. Recently, those readings began to shift. Temperatures rose slightly in certain underwater vents. Gas emissions altered composition. Small seismic tremors appeared beneath the caldera floor. Each of these signs alone would normally be dismissed as routine volcanic behavior. Volcanoes breathe, they expand, they settle. Individually, such signals are considered natural adjustments within a living geological system, but taken together, they tell a different story. When temperature variation, gas fluctuation, and microquakes begin appearing simultaneously, scientists stop calling it background activity. They start calling it a pattern. And patterns matter, because patterns often appear before major geological events. They reveal stress building where rock meets magma. They expose pressure redistributing through underground chambers. They signal that something below is reorganizing its internal structure. Researchers analyzing recent data notice something even more unsettling. One offshore monitoring buoy captured a rhythmic pulse, unlike anything previously recorded in this region. It wasn't random vibration. It wasn't ocean interference. It was a consistent, repeating signal rising from deep beneath the seafloor. The pattern resembles seismic signatures documented before eruptions in other volcanic zones around the world. Not identical, but close enough to raise concern among specialists who study volcanic precursors. This doesn't prove an eruption is coming, but it proves something is changing, and change inside a volcano is never meaningless. Right now, the system remains stable on the surface. There is no explosion, no ash plume, no visible lava. Yet deep underground forces older than civilization are shifting position, redistributing energy, and testing the strength of the rock that contains them. The question is no longer whether Santorini is active. The question is what kind of activity is beginning. Viewer question: if you live near Santorini, would you stay or evacuate? Type stay or run. Volcanoes don't simply erupt, they unleash sequences. One violent shift underground can trigger a cascade of consequences above and below the surface. Rock collapses, pressure fractures, shockwaves race through water and stone. The event itself is only the beginning. What follows is often far more destructive. Santorini's ancient eruption proved that reality. When this volcanic system last exploded at full force, it didn't just release lava, it reshaped geography. Sections of land collapsed inward. Walls of water surged outward. Coastlines across the Mediterranean were permanently altered. Entire settlements disappeared, buried beneath ash and sea. What had once been thriving civilizations turned into silent ruins preserved in volcanic debris. Archaeologists studying those ruins found evidence of sudden destruction, buildings abandoned mid-use, tools left behind, lives interrupted in a single catastrophic moment. For historians, the eruption wasn't just a geological event, it was a turning point that echoed through myth and legend. Some researchers even believe this very disaster helped inspire ancient stories about powerful lost cities swallowed by nature's fury. That history matters now, because modern data suggests the current volcanic system may not be isolated. Deep scan imaging indicates a possible connection between Santorini's main magma reservoir and another molten pocket lying offshore beneath the seafloor. These reservoirs may be linked by narrow channels of partially melted rock, pathways capable of transferring heat and pressure between chambers. If that connection is real, it changes the risk entirely. Volcanic chambers behave like pressurized containers. When one ruptures, stress doesn't vanish, it transfers. Energy moves through surrounding rock, searching for the next weak point. If a secondary chamber is already under strain, the transferred force can push it past its limit. One rupture, then another, a chain reaction beneath the ocean floor. This is the scenario geophysicists watch for most carefully. Not a single eruption, but a sequence. Multiple releases of pressure occurring in stages, each one destabilizing the region further. Such events can amplify shock waves, intensify seismic motion, and increase the likelihood of underwater landslides capable of generating powerful sea surges. Right now, there is no confirmed rupture, no eruption plume, no visible warning to the naked eye. Yet, the structural possibility of interconnected magma systems means scientists cannot treat Santorini as a simple, isolated volcano. It is part of a deeper network whose full boundaries are still being studied, and networks can fail suddenly. The real danger is not what has happened, it's what could happen next. Viewer question. Should governments warn tourists now or wait for proof? Type warn or wait. The official statement is calm, controlled, reassuring, no immediate danger. On paper, those words sound safe, measured, responsible, the kind of language designed to prevent panic and maintain order. But in scientific environments, official statements rarely tell the whole story. They reveal conclusions, not concerns. And right now, behind laboratory doors and monitoring stations, concern is growing. Because while public reports remain steady, scientific activity has intensified. Monitoring teams have quietly doubled their shifts, rotating specialists around the clock to watch live seismic feeds. New sensors have been installed in strategic positions across the caldera, placed with urgency rather than routine planning. Our research vessels have conducted additional passes over key zones, gathering fresh data from the seafloor. Certain study areas have even been temporarily restricted, limiting access while measurements continue. These actions are not dramatic announcements, they are subtle operational changes. But in scientific culture, behavior speaks louder than statements. When experts accelerate observation, it usually means one thing. They are watching something closely. The question is, why? If conditions were completely stable, monitoring would remain routine. Instruments would continue recording at standard intervals. Teams would follow normal schedules. There would be no need for sudden expansion of surveillance or rapid deployment of new equipment. Yet that is exactly what is happening. Recent satellite radar analysis has detected a faint but measurable swelling along one side of Santorini's caldera. The change is small, like only millimeters, but in volcanology, even millimeters matter. Ground deformation is one of the most reliable indicators scientists track, because the Earth's surface often responds to pressure long before an eruption ever occurs. Swelling means force is building underground. Force means magma is shifting position. Magma movement means the system is evolving. Volcanoes rarely remain static once internal motion begins. They adjust, they redistribute stress. They search for release points within surrounding rock. Sometimes that process stabilizes naturally. Other times it escalates. Right now, no one is declaring danger. But no one is dismissing the signals either. Experts understand that volcanic systems operate on their own timelines, not human predictions. The Earth does not consult forecasts before it moves. Something beneath Santorini is changing, slowly, quietly, persistently, and scientists are watching every second of it. Is this early warning science working, or are we already too late? Type early or late. Right now, there is no eruption, no explosion tearing the sky, no ash clouds swallowing the horizon, no rivers of fire sliding into the sea. Only signals. Signals instruments detect. But scientists cannot fully explain. Subtle tremors, deep vibrations, pressure pulses rising from beneath layers of ancient rock, each one small on its own. Yet, together they form a pattern that refuses to be ignored. History has shown a hard truth about volcanoes. They rarely repeat warnings. When they move once, they may move again without notice. Not louder, not clearer, just suddenly. That is what makes the current data unsettling, because the strongest tremor recorded this month did not originate from the volcano's main crater, the place experts watch most closely. It came from somewhere else. A fracture zone discovered only recently during deep geological scans. A hidden fault line running beneath the seafloor, far from the island's most visible volcanic vents. Fractures like this matter. They act as escape routes for pressure trapped underground. If magma finds one of these pathways and forces it open, the eruption won't begin where scientists expect. It could break through at a completely new point. Not predicted, not mapped, not prepared. Anywhere. Anytime. That possibility is what keeps monitoring stations active day and night. Not fear, but uncertainty. Because uncertainty is the one factor science cannot eliminate. It can measure pressure, it can track heat, it can analyze gas, but it cannot promise when the Earth will decide to release its force. Right now, Santorini is quiet, but quiet does not always mean safe. Prediction. Time. Will Santorini erupt in our lifetime? Type yes, no, or soon. Somewhere beneath the Mediterranean, something ancient is shifting, and the world is watching, waiting for the next signal.